In this lecture, we will discuss Einthoven's triangle. Einthoven's triangle describes the relationship between limb leads and electrodes. There are four main electrodes used: the left arm, the right arm, the left leg, and the right leg, or neutral electrode. So if you look here, we can see them. Here's our right arm, okay? Imagine this is the patient here, okay? And we're looking, this is the right side. This is the left side. This is the left arm here. This is the left leg, so the left leg here. And this is our right leg or neutral electrode. So there's four there. Now by adding or subtracting the voltages from the recording electrodes, we get the magnitude and direction of each vector that is manifested in the EKG lead. The bipolar limb leads include leads 1, 2, and 3. And then the augmented unipolar leads include leads AVL, AVF, and AVR. Okay, so first we have our bipolar leads, which are leads 1, lead 2, and lead 3. Okay, and then we have the augmented unipolar leads, which are here. Here's AVL, here's AVF, and here's AVR. Okay, let's now look at these bipolar and augmented unipolar leads, how they're calculated and where they're directed. So lead 1 is calculated by subtracting the voltages recorded in the right arm from those recorded in the left arm. It is directed towards 0 degrees in the frontal plane. So let's just erase this here so we have something clean to work with. Okay, so now we're looking at lead 1. Okay, so lead 1 is this one here. And notice it's the left arm minus the right arm, okay? So here's our left arm, here's our right arm, and then here's lead 1, okay? So we're going in this direction, and then we're doing the left arm, which is here, minus the right arm gives us lead 1. And it's directed at 0 degrees. So here, if you look here in our frontal plane, this is lead 1 directed at 0 degrees. So just to review, this would be 0 degrees. This would be positive 90 degrees. This is plus or minus 180 degrees. And this is negative 90 degrees. Okay, so that's lead 1 directed at 0 degrees, and we do the left arm minus the right arm. Then we have lead 2, and this is calculated by subtracting the voltage recorded in the right arm from that recorded in the left leg. It is directed at positive 60 degrees in the frontal plane. Okay, so now we have lead 2, which is this one here. And you can see it here, and it's going in this direction. We're doing the left leg minus the right arm. Okay, so left leg minus right arm voltages give us lead 2. In this one, it's directed at positive 60 degrees. So here's lead 2 in our frontal plane, and it's directed at positive 60. So again, this would be lead 1. This is about positive 60 degrees, where we have lead 2, okay? So we have lead 1 and lead 2. Next we have lead 3, and this is calculated by subtracting the voltage recorded in the left arm from that recorded in the left leg. And this one is directed at positive 120 degrees in the frontal plane. So now we have lead 3, okay? And lead 3 is this one here. And we're saying it's the left leg minus the left arm. So here's lead 3. Directed in this direction, and we have the left leg minus the left arm. So left leg minus left arm voltages give us lead 3, and this is directed at positive 120 degrees. Okay, so this would be lead 3 would be about right here, which is a positive 120 degrees. And those are the three bipolar leads, 1, 2, and 3. Okay, so we have the bipolar leads. Now let's look at the augmented unipolar leads. So lead AVL is directed at negative 30 degrees in the frontal plane, and we can calculate it by first adding the voltages in the right arm in the left leg, and then dividing by 2, and then we take that and subtract that number from the voltage in the left arm. Okay, so now we're at the augmented leads, and we're looking first at AVL. Okay, so right arm plus left leg divided by 2, and then you use that number, subtract it from the left arm. Okay, and we're looking at AVL, which is directed here at negative 30 degrees. Okay, so negative 30 degrees is about here, and this is lead AVL, okay? And AVL, notice it's up here, okay? How it's heading in this direction. So that's lead AVL. Then we have lead AVF, and this is directed at positive 90 degrees in the frontal plane. We can calculate it by first adding the voltages in the left arm and the right arm, dividing by 2, and then subtracting that number from the voltage in the left leg, okay? So this is AVF. which is heading now in this direction. Here's AVF, okay? And you can see it down here at positive 90 degrees. Here's positive 90 degrees, and this is where lead AVF is, okay? So we have lead AVL and AVF, and now we have lead AVR, which is directed at negative 150 degrees in the frontal plane. We can calculate it by first adding the voltages in the left arm, the left leg, and dividing by 2. Then we subtract that number from the voltage in the right arm, okay? So AVR is this one here, and notice what's going in this direction. All right, AVR here at negative 150 degrees, okay? So you can imagine it being about right here. So here's negative 150 degrees, and this is where lead AVR sits, okay? So yes, we have all these formulas that you can review. You might not find them so helpful at this point, but they're there if you want them. The main thing I want you to take away is where the bipolar and augmented unipolar leads are, where they're directed, and this will play an important part as we move forward. Now lastly, we have something called the Wilson's central terminus, which is sometimes referred to as the directionless zero lead. And this is because it is the average of the signals coming from the limb leads. It is calculated by adding all the voltages from the right arm, the left arm, and the left leg, and then dividing it by 3. Okay, so you can see here the Wilson's central terminus, okay, which is sometimes called the directionless zero lead. And we get that by taking the average of the limb leads, so right arm, left leg, and then doing 1/3 of that, or dividing it by 3, okay? So why are we even talking about this? Well, it's because we will be looking at lead reversal next, and you'll see that understanding Einthoven's triangle and the mathematical derivations of each lead will prove to be helpful when looking at the EKG patterns produced by each type of limb lead reversal, okay? So let's briefly review what we discussed before we end here. So Einthoven's triangle describes the relationship between the limb leads and the electrodes, okay? We said there are 4 electrodes, the left arm, the right arm, the left leg, and then the right leg or neutral electrode, okay? We said that these leads each reflect the specific vector of magnitude and direction, and it's produced by the voltage differences from the recording electrodes. We talked about the bipolar leads, 1, 2, and 3, where they're directed, the augmented leads, as well as where those are directed, and then we discussed Wilson's central terminus. Now remember, lead 1 is at 0 degrees, lead 2 at positive 60 degrees, lead 3 positive 120 degrees, lead AVL negative 30 degrees, lead AVF down here at positive 90 degrees, and then we have lead AVR at negative 150 degrees. Well, that's the end of this lecture. We discussed Einthoven's triangle. I hope you learned something.